Hi everyone and welcome back to NotesNaka. Today is day 11 of the lead coding challenge, and for today's problem we have the flood fill problem. Now this problem has been asked in many companies like Amazon and all, and this is a very important problem as well. So the basic background of this problem is if you imagine paint, when we fill the color, then it when we fill in a shape, then it fills the entire region and it does not overlap the region and does not go out of the line. So that is the basic thing that we are trying to implement in this problem. So what we will be given is a image, a 2D array of integers where we will be given pixel values. So and then after we will be given a coordinate where the color has to be put, and it will then fill the entire place that has to be filled. So if you imagine in paint, if you have a circle and if you go and bring your paint inside of the circle and then click, then it will fill the entire circle. That is what we are trying to do over here as well. So we are given a coordinate, we are given an image that we have to fill, and also the new color that has to be filled in instead of that color. So this we can see this example, and for a better understanding I have explained this example on pen and paper, so let's check out that. Now let's understand the question with a simple problem. So this is the problem. We have a matrix of image. It's a 2D matrix, and in the first row we have 111, second 110, and then 101. Now we have also given a coordinate where we have to fill the where we have to start filling the color. That is SR comma SC. That is 1 comma 1. So in this matrix 1 comma 1 will be this position, and the new color to fill is 2. So what we do is first of all go to that place where we have to start, and at that place the first thing we have to do is check if it is equal to the new color or not. If it is already equal to the new color, that means we do not really have to do anything and just return this image. This is the base case of this problem, and this is very important to note as well. And if it is not equal to the new color, that means we are filling a new color. So we will first replace the first one with 2. So we will have 2 in the middle. Now what we have to do is check in all of its sides. If any of them is same to this number, then we will have to change them too. For example, on the right of 1 we have 0. So 0 will remain 0 as it is not 1 and it will not get filled. And again on the left side we can see 1. So 1 will be changed into 2. On the top of it we can see 1. 1 will be changed into 2, and below it is 0, so 0 will not be changed. Now if we see, now we have to check it for all the others that we have been changing, and all the others we can see for 2. On the right we have 1, so it will be changed to 2. Similarly this will also be changed to 2, and this will also be changed to 2. Now this will not be changed to 2 because we will compare for this and this number. Since these have not been changed, then anything after that will also not be changed, so it will remain 1. So this is our final image. So to solve this problem, what we will do is use recursion. So we will make one main function from which we will send the coordinates, new color, our image matrix, and also CMP, that is what is the number that we are comparing. So we will first extract this number and store it in CMP, and then call a new function where we will check all of the values. So when we call the new function, the first thing we will do is change this number into 2. So we changed it into 2. After that we will have 4 cases. Check on this side, this side, this side, and this side. Now first we will start by checking this side. Now if this position, that is the SC plus 1 and SR will remain the same. So if SC plus 1 is less than image of sr dot size. This is the syntax that we will use in vectors. So we will first check if it does exist, then only we will access this element, and if, after accessing, we will compare it with CMP, and if they are equal, that means we will change this. So recursively we will call the same function again and make our new sr comma sc to this position. So it will then change this number, but right now this number will not be changed, so the recursion will not be called on this one. It will then check this one. Now this is sc. If sc is greater than or equal to 0, then we will access it. So if it is equal to cmp, that means we will have to call recursion on this number. So when we call recursion, the first thing it will do is change this one, so it will also become 2. Now this is also 2, and then for this number it will keep on checking on all the other sides. So now if it checks this one, then it will call recursion on this and it will become 2, and all the recursive calls will return the image matrix, and finally at the end of the recursion stack it will return this whole image, and that will be our final answer. Now let's check out the code for this. I hope you understood the basic background of the problem and the algorithm behind it. Now let's check out the code. So this is our main function, function where the image and the source and sr, sc and new color is been given. So the first thing we do is check if the coordinates that has been given to us is equal to the new color or not. If they are already equal, that means we do not really have to do anything on the image and we just return that image. After that, we make a CMP value, which it is an integer, and store our image SR and SC inside it. So that is the value that we will be comparing in every iteration. And after that, we are returning the flood fill answer. This is a new function that I have created myself, and inside that I am sending the image SR, SC, new color and CMP. So in the new function, what we do over here is, first of all, change the value. So image SR and SC will become the new color. That is the first step. And then after that, we have 4 cases. So if SC plus 1 is less than image of SR dot size. This is a syntax of vectors STL. So that's what I have used. And then I have compared it with CMP. If the value is equal to compare value, then we will recursively call it on that value. So we will pass SR, SC plus 1, new color and CMP. Similarly, I have written the other cases as well. If SC minus 1, we will check on 4 sides. So if it is SC minus 1 is greater than or equal to 0, then it is also equal to compare, then we will send SC minus 1 and recursively call the function again. And at the end of every recursion call, it will return an image, and the image will be returned, and after the last recursive call of the stack, then the image will be returned to this function and it will return it back to the main function. So this is the code of the problem flood fill, and let's run the code and see. I'm using a custom test over here, and you can see the answer has been accepted, and if I submit it, then you can see it has been accepted. So this was the problem for today. I hope you liked what you saw, and if you did, then please do give us a thumbs up and also subscribe to our channel. And if you have any feedback, then leave it down in the comment. We will be more than happy to read it. Thank you for watching and have a nice day. Bye bye. Take care.